Hello everybody, I'm Scott Skanes and welcome to my math class. Is that how I should talk? I don't know, maybe not. Let me show you one thing. I'm sure I said this yesterday, but the assignment was moved to Sunday. So make sure you keep an eye on the news feed. This is for section 3, but same idea. Assignment 2 is on the last 30 minutes of class on Sunday. So not Thursday. That'll give us a little bit more time to get things done. And I've also posted the notes, the handwritten solutions, my notes. They weren't working before, so I fixed that. Anyway, just something to bring up. Now, yesterday, like I said, we didn't get to piecewise, so let's just jump right straight into piecewise functions. And another, basically what piecewise means is instead of having one function with one set of domain and one set of range, which again, domain and range is what we did yesterday, we have one function that's basically two or more functions pieced together. So it's, that's why it's called piecewise. I'll say two or more functions. And I'm gonna use the word pieced together. They're kind of like stuck together side by side. So let me just give you an example, because there's an example here. X minus 2x, that is this function here, okay? That's what that looks like. I'll just give you that for free. I'll give you the graph. And then the function 0 is, of course, it's a straight line. So I'll just color that in here. That's our first function, and that's our second function. Let me make it crystal clear. This is our function x minus 2x. It only exists for the beginning of this function. And on the other side here, we have the function 0, or f of x equals 0. So how do we know how this function is built? Well, let's go a little bit further and look at the range here. It exists from 0 to 4. So that's when x is between 0 and 4, equal to 0, equal to 4, and everything in between, it is that function. Everything after 4, it becomes a different function that's just attached to it. So everything greater than 4, if x is greater than 4, it becomes the other function. So it's two functions or three functions or four functions all attached to each other, and they just have different domains and ranges because of that. So let me show you how one of these examples works. I'll give you a little bit of break here. I'm not going to ask a question like this on a test because they're a little bit tricky for what I want to accomplish. So you can go ahead and skip that. But I do want to do these questions. All right, I'm not going to have you graph them, but I will ask you to evaluate them, which means put in the x value, tell me what you get back. So first things first, let's try to understand this question. By the way, I said this before, but these QR codes here, they're not just random glitches on the page. Some of you, many of you probably already know this. If you go to your phone, open up a QR code reader and just point it at the screen on the QR code, it'll bring up something that I've created that I think would be helpful to understand this question. In this case, I've made the piecewise function. So you can bring that up if you have time. But let's get to the point since I'm trying to make up for lost time. For this piecewise function, piecewise means two or more pieces together. I want you to evaluate what is the value of the function at the given point. So for example, let's call this function 1, and let's call this function 2. If Tom did this, by the way, but I'll just assume that you don't know that. While I'm thinking about that, the stuff that Tom covers, I normally do not cover. There is a lot of stuff that he covers that I don't. You are still responsible for that. In fact, what he covers is the core content of the course. What I cover is the practice problems. Now, they're very similar, but if you miss his explanations and examples, you are quite literally missing half of the course. So keep that in mind. You are responsible to watch these videos. So don't just let them slide and think you're going to be okay without them. They are very important. I know I'm a pretty interesting kind of guy. I know that these classes are exciting, but please listen to Mr. Tom as well. He's as exciting in his own way. Anyway, let me get to the point. Look at this function. We have this this function It exists when x is less than or equal to 2. This function is what it is between 2 and 5. When we evaluate this, we need to choose, okay, which function do I use? So for example, for x, if the function is being evaluated at -1, which type of function am I using? Am I using the first one or the second one? So I'd like you to write it in the chat. Number 1 or number 2, which one do I use? I want to put the value -1 into the function. Which function am I allowed to use? Anybody? Silence. Crickets. So it's telling me, it's telling me that the first function exists when x is less than 2. -1 is less than 2. So to evaluate this, I need to use the first function. The second one here, 2. Which function here, which one has x equals 2 inside of it? Well, the first one again. The first one exists for when x is less than 2 or equal to 2. So I would use that function. Let me see if you're following. The next step, 4. When x is 4, which function do I use? The first one or the second one? Anybody? There's so many of you here. I know you can do this. Which function exists for when x can be 4? Yeah, the second one, exactly. Because the second function exists from 2 to 5. What about the fourth one? It's kind of a trick question. Anybody going to risk telling me? The last one, you'll notice you can't use either function. Because look, this function, I'll just make a little sketch here. The first function exists from anything less than 2. That's when the first one would exist. The second one only exists between 2 and 5. Anything bigger than that, it doesn't exist. Yeah, Zara, you caught it as well. We can't use it because if we look at this, I'll try to get the whole picture here. Sorry if it gets too small. We're not allowed to use that part of the function because it doesn't exist there. And I'll draw the picture soon so you can see it. But let me evaluate it and I'll come back to that thought. So the function, first function when x is -1 is 1/2, -1 plus 4. What does that give me? And again, I'm just replacing the x with what it wants out of this. So the final answer for this would give me 1.5 or 3/2. Okay, that's my answer for this question. For the second one, if I put 2 in for x, what do I get? Well, that looks like 6 divided by 2. 6 divided by 2 should give me a 3. What about the second function when second function when x is 4 would be 4 squared plus 5 times 4 is 10. Hopefully you can calculate this. I'm just kicking through it as quickly as I can. If anyone, you should get 6. And the last one, we can say DNE. And if you know what that means, it means it does not exist. Okay, it doesn't exist. And that's the idea. Now, for those of you that would rather see pictures of this, I'm not going to have you graph it, but I do want you to at least look and see what I'm about to do, which I'm going to graph it in Desmos, so you can get a good idea of how this looks. You know, what is the picture behind these equations? So you don't need to be able to do this yourself. Just sit back and watch the magic happen. So when x is less than or equal to 2, my function is 1/2, x plus 4. So it looks like this, okay? It's part of a line that just stops. For the second part, when 2 is less than x but less than or equal to 5, my function is x squared minus 5x plus 10. All right, this is what this function looks like. It's a little crazy looking, but it is what it is, okay? I get this weird looking function. Let me make it a little more clear. All right, now let's look at our values. I'll try to annotate this so you can actually watch me. When x is -1, -1 is over here. That's -1. So of course, I need to use the first function because that's the line, that's what it is at that point. Anything less than 2 is that first function. The second point I'm checking is 2. And that needs to use which function, the first one or the second? Well, it's less than or equal to 2. So it's actually still using the first function, whose value is 3. So when it's 2, we get a 3 for the first one. When it's -1, I get a 3 over 2. I'll try one more value. When x is 4, it's over here. It's going to use the second function. So 4, and then my value is 6. All right, this is what it means to be a piecewise function. You have two functions or more stuck together, and it's like a game. When do I use which function? Well, you just follow the rules that are given by the x values. That's the big idea, okay? So hopefully that didn't throw you off. I hope that makes a little bit of sense to you. Once again, I'm not going to ask you to graph the function, but you should be able to do this evaluation. This is expected for the test, okay? Or the assignment, I would definitely ask you to evaluate. Any questions on that before I move on? Going once, going twice. Sold to the highest bidder. Doesn't even make sense. Sorry. Okay, let's move on. Lots of practice. That's all things you can do at home. You are expected to be able to evaluate these. So if you want to do the practice, of course, you should be doing the evaluations. You don't need to graph it. Once again, you can evaluate it. And now we start our class for realsies, because we were supposed to do that yesterday. And it's 4:04, so I almost did it in 10 minutes, almost. Composite functions. Does anyone know what a composite function is? Well, if you watched Tom's videos, you would know what it is. If you didn't watch Tom's videos, I'm here to save you, but please make sure that you watch them. A composite function. I had a different color here. What was it? Green. A composite function is when we put one function inside another function as x. And what I mean by that, I'll just have a little dream sequence over here to the side. So don't get too stressed out. I'm just making a little note here. Let's just say we had two functions. Or first of all, let's say we had one function, which is x squared. Okay, nice and simple, nice quadratic function. What if you know, we wanted to put 2 in for this? So when x is 2, that's easy peasy now. Anytime we see anytime we see x, we just replace it with 2. We get 2 squared and we get a 4. Yeah. So that's easy. That's called evaluating the function. We literally just did that for piecewise. All right. We've been doing it the whole unit. Now, what we're going to do today is not put numbers in. We're going to put functions in. So to make things a little trickier, this will be our original f of x. We're going to bring another player in and call it g of x. And that'll be its own function with its own rules. Let's just say it's 2x plus 1. All right, that's its own function. It just kind of creeps on in and it's like, hey, I'm here to play. And you're like, okay, cool, 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 fine, let's huddle up. So what we need to do, instead of replacing x with numbers, we're going to replace x with functions. And how does this look? Well, I literally am going to take this whole function here and I'll stick it right in for all the x's of the other function. What that's called is f of g of x, or in other words, f of g. It's called f of g. F of g. F with g inside. It's like it takes g and it kind of just like puts it, it's like it's hugging it, right? It's got it inside, it's hanging out, and now it'll replace all the x's. So let's replace that color. I'll just, every time I'll make it a purple, I guess. And what do we have here? My Zoom just crashed. So hopefully you can still hear me, see me, and so on. My internet just crashed on my other computer. Hopefully you're still around. It's still recording anyway, hopefully. What was I doing? So f of g. So f of x, note that this is x squared. I need to take this x and replace it with this function every time. So I have 2x plus 1 and square that. That's what's happening. So one second, I need to fix my screen here. My Zoom completely crashed, which has never happened before. So considering all the things that could go wrong, not so bad. So anyway, this would be what we get. And if we simplify this, it would be 4x squared plus 4x plus 1. So what a composite function is we have one function with x's in it. We take the other function and we put it in, replacing all the x's. Is there anything I can clarify before I do a few examples on this? You guys are such a quiet class. If this was face-to-face, I would go around there and I'd shake you awake, be like, come on, tell me what you need. You're paying money for this. You've got a tutor here with 2 degrees or 3 degrees and a master's degree and blah, 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 blah. Use me. But maybe you're okay. Nah. Okay. Now, the other thing I'll say in my little example is you can choose to put the function in any order. So let's put f of x inside of this. And what this will be, we have normally, 2x plus 1. We're going to replace this x with the other function. We're going to put x squared in every time we saw the x. And that will be plus 1. So this actually just gives us 2x squared plus 1. And we're done. Okay? So we can put one function into the other, or we can put the other function into the first function. And this is the big idea behind composite functions. So to summarize this, it's saying, first of all, this is pronounced f of g. So when you hear me say that, this stuff, all of this, is pronounced g of f, in case I say that and you have no idea what I'm talking about. And finally, you just replace every x with a function, or with the function, whatever function you've been asked to replace it with. So example 1 was already done by Tom. I'm not going to go back over that because I had to make up time with the piecewise functions, but I'll do plenty of examples with you so that you get an idea of how to do these things. So let's go ahead and do this example here. Tom did C, so I'll do A, B, and D. We have 2 functions. We have f of x is 1 over x, and we have g of x is 3x minus 6. And the first question is, find g of x. Notice we're putting g inside f. We have f on the outside, and g is inside. It's being held inside. So it's, where can I find Tom's videos? On YouTube. So math, phys, CNAQ. Or you can find the link on the homepage. I linked them, sorry for those of you that don't know what I'm talking about, but every single class, I don't know how you don't know this, but the lessons are always right there in the front of the page. Okay, so you should know that. I'm actually quite shocked that you don't, but I'm glad that you asked because now you know. Okay, so back to the composite functions. It is in D2O. It's right here. And then you click on it and it brings you to the video. So I'm not entirely sure what you're talking about, Yasser, but if I've done something that you want me to change, I'm happy to talk about it. So let me finish the question here. we have f of g of x. So really what we're doing is finding the function f, putting 3x minus 6 in every time we see an x. So really what this gives is 1 over 3x minus 6. And this is actually done. There's no more to do in this question. That is our final answer. Okay, so now that you know how to do the first set here, the first f of g, I want you to try to do g of f of x. And tell me what that final answer is. It should take you only about 10 or 15 seconds. Okay, so try that. So I'd like it when you've tried this, and hopefully you are trying it. Tell me what your final answer is. Remember, we're getting g, replacing all x's with 1 over 6. Anybody? I feel like we're all shy today or busy with something else, but you got to try this stuff. And if you don't tell me at least something along the lines of you doing this, I have no way of knowing. What I normally do is I'll just call on specific people, but not everyone feels comfortable with that. So I'd rather you volunteer. Did anyone get B? Anybody? It's like pulling teeth. Anybody? Is there anybody out there? Does anyone like Pink Floyd? They're a good band. 3 over x minus 6. Thank you, Zada. That's exactly what I got. So I'm taking my g function. Ain't nothing but a g thing. 1 over 6, and then minus 6. And I'm going to simplify that. So that would be 3 over x minus 6. And that's our answer. Perfect. Okay, good. Thank you, Zada. And hopefully the rest of you are just being sheepish and don't want to give their answer. If you're not doing anything, then you're really wasting some really valuable opportunities to practice. And the more you practice over the longer span of time, the better you're going to be. I always like to say, you know, studying right before a test is like trying to eat all your meals for the week in one night. It doesn't make sense. You can only put so much in your body before you shut down. Although some people try really hard during you know, Ramadan to put as much food as they can. But anyway, my point is don't wait to study, try to engage. Let's finish this question. C was done on the video, I won't do it now. Evaluate g of f of x for x equals 12. So g of f when x is 12. Notice we have that function. This is g of f of x. So we just take that answer and replace the x. So what is it? It is 3 over 12 minus 6. And so when we solve that, we should get negative 23 over 4. Okay, so that's where that comes from. Let me just make a highlight. I don't like to use too much highlighting, but I want to make sure that you know what I'm talking about. G of f of x is this. And so I'm putting x into that function. You know, I'm putting 12 in to this, which is why it's 3 over 12 minus 6. That's where this all comes from. So the main thing with students is you sometimes get a little confused which function we're looking at. Hopefully it's clear which function we're looking at. assuming that everyone's paying attention. Again, it's excruciating teaching like this. It's very draining for me and probably annoying for many students too. But we do what we can. So I'm just happy you're all still showing up. I'm supposed to have 19 people in this class. I've never even seen close to 19 people in the class yet. So thanks for showing up, keeping me company a little bit, and making this whole crazy self-isolation thing a little bit easier for everyone. All right, so let's try some of the practice. I will do one more example for you, but while I do that, I would like you to try question 2, okay? I want you to do all 4 of them, A, B, C, and D, okay? I've mentioned here that there's a shortcut, and there is a shortcut. It's done in Tom's videos. I'm not going to show it today because it's just as fast to do it this way. All right, so please try question 2 here. I'm going to give you, let's say 3 minutes, come back at 4:20, and tell me what your answers are, okay? If you don't tell me specifically what your answers are, I'm just going to call out for people in the chat, okay? So I want at least 3 people to give me their answer. I'll give you until 4:21. A, B, C, and D. Okay, so it's 4:21. So thank you, Hamza. You're the only person who's replied so far, but I hope others are working on it. I asked you to do all of 2. I just wrote out my answers for 1 so that you'd have more workings. So let me just finish that. F of g of x is this. G g of f of x is this. And then now we can work on 2. So let's see. You're saying 2 is 16 over 3, which I think is correct. And you got d to be 2. I also think that's correct. I'm going to do out a and b so that we have something to work with. But you know, you're correct. So well done. I'm going to put in this one, g is being replaced, sorry, all the x's and f are being replaced with the function g. So f of g of x is the same as f of 2x minus 7. All of the x's are replaced with 2x minus 7. All the x's in function f. So that's 1 over 2x minus 7. And then we're going to have plus 5. We're not going to simplify that because when we have fractions like this, it's just a little bit more effort than we need to put into this. We don't need to fully simplify most of the time because it only makes it more complicated to simplify, not easier. So this is a perfectly fine final answer. In the second question, we want g and f is inside of it. So it's 1 over x plus 5 is what we're going to replace all our x's with. It's a plus. I'm going to change up my color scheme. And b is 2 over x plus 3. Yep, I think you're right. So I'm going to replace all the x's in g. That's this one. That's 2. I'm going to replace that x with 1 over 5 plus 5. I still have the minus 7 on the outside. And then, of course, we need to multiply through. And it looks like we're going to get what Hamza got here. This is 2 over x. That's 2 times 1 over x is 2 over x. 2 times 5, of course, is 10. So we'll just write the 10, keep the minus 7. And then we have 2 over x plus 3. So you're exactly right. Thank you. I guess maybe you're all tired. But again, all I can ask is that you try to keep your brain on as much as possible because this course isn't going away. And the middle of the course is the hardest part. So you want to get most of the marks that you can in the beginning so that when the course gets tricky, you can stand to lose a couple marks if you make some mistakes in the harder parts of the course. Okay, so I'll go ahead and do C and D. We already have f of g of x. It's this one. So we just put 5 in for that. So 1 over 2 times 5 minus 7 plus 5. If you solve that, let me see if I have, yeah, plus 5. Yeah, so it should give us 16 over 3 if you solve that out. The second question, we have f of g of x. It's this one. Let me just highlight it so it's crystal clear here. So we're going to get the final answer by using that. So that question, let me see, where's my x? 2 over x. Sorry, I don't know if anyone noticed that. 2 over x. I'll write out 2 over negative 2 plus 3. 2 over negative 2 is negative 1 plus 3 is 2. So that's my final answer now. Okay, how is that? I'm not getting a lot of feedback today. Can I just have at least like a thumbs up in the chat so I can see if I need to review anything? I am a human. It is nice to have a little bit of feedback from more than like one student, although I don't have a problem with having one student. All good? I did it, but I wasn't sure of the answers I got. That's fine, and you don't need to get the right answers. That's the whole point. It's called practice for a reason. But I just ask that you do the practice. That's all I can ever ask. I can't come over there and make sure you're doing it. I can just hope to motivate you enough to try it yourself and give you the tools to solve it yourself. Cool, so let's move on. I was gonna do a few more questions, but we don't need to. Not on this topic anymore. The only one I really want to cover is, of course, these can all be homework. Anything I skip is always something that you should try before the test. So these are all just homework, extra practice, and so on. They're all similar. I do want to do 5, just the beginning of 5, because I want to show you when you should simplify and when you probably should just leave it. Let me show you this. F of g of x is going to be f with g inside. So I'm going to put g in there. That's x squared minus 5 is the g plus 7. Replace that with g. The final answer here is just 3 over x squared plus 2. That's not the one I was concerned about. That's not why I'm doing this question. The reason I'm doing it is to show you b. In b here, we're putting, it's g of f of x. So we're putting the function f inside of the g function. So we need to replace x with the function. So I'll say 3 over, oops, x plus 7. I'll need to square that. Let me just be clear. This is our old x. Square it, take away 5. If you were to see this on your own, you would probably look at that and say, am I done, or do I need to expand it out? Do I need to multiply on top and bottom, or get the power on top and bottom? And I'm just going to say, no, you do not, because that's good enough. We can easily use that function and replace the x. So to be clear, if you see fractions, or fractions squared. Sorry, my handwriting isn't great today. Or fractions squared, don't simplify. You know, don't bother opening the brackets and multiplying everything out. It's good enough. It can easily have its x replaced by something else. So there's no reason to spend all that time multiplying it out. It's not saving you any time, okay? I'm not gonna do C and D. I'm just gonna give you the final answers in case you want to try them yourself, which you always should. This is 1 over 34. And the final answer for D is negative 16 over 25. So the full solutions will be online for that, but you should be able to get that yourself. Okay, so we have one more topic to cover today, and we still have 50 minutes, lots of time left. Is there anything I can go back over for composites, or would you like me to do one more example? I guess my question is, do you want me to do another example or just move on? So Hamza, you want to move on. Does anyone want me to try another example? Okay, Ibrahim wants one more example. Yasser is his classic nah. Someday you'll surprise me. You'll need more practice. Okay, let me pick a quick example then, just so that we are crystal clear on this. They're not long. So this question, we've got 2 functions, f of x, g of x. First question, put g in the function. So I'm going to copy out the first function f, and every time I see an x, replace it with g. So x minus 1, square that, plus 2. This one I will expand because it's not a fraction. It's a square, but it's not a fraction. And what you'll get is 2x squared minus 2x plus 1 plus 2. And then that simplifies to this. Okay. That's what I got anyway. You should always check my work, but pretty sure it's right. Just going to move this over a little bit, make it a little smaller. Okay. So again, f of g means put g inside f. The next question, put f in g. So we have the function g, which is x minus 1. Replace all the x's with the function. So put the function f inside and subtract 1. Well, that's pretty simple. It's the same thing as 2x squared plus 2 minus 1. So these two things just come together. We end up with 2x squared plus 1. All right, that's our second function. That's g of f. I'll complete this question. Why not? I'll do it fully this time. We'll know f of g of x is this. G of f of x is this. This question is saying evaluate f of g for x equals -2. So 2, -2 in for x, minus 4, -2 in for x, plus 4. What this gets, or what you will get if you simplify this, you should get 20. You should check that yourself, because obviously it's always important to check the work, and it's easy for me to make a mistake. Let's see here. Second and last question, g of f. So g of f is the purple function above. Replace all the x's with -2. -2 squared, add 1. -2 squared is 4, times 2 is 8, plus 1 is 9. The answer should be 9. Halas, I think I'm good on composite functions. I hope that you're good on composite functions too. This is a very simple topic once you understand what you're doing. You just take a function, put it into the other function. I just wanted to make sure you had enough examples, because it's really easy marks when it comes down to assignments and tests. Okay, so now I'm definitely going to move on. If you need to take a little longer to write it down, of course, I post these online, but just take a picture if you need to. It's fine. 1, 2, 3. Okay. So this is the second topic of the day, which is the inverse of a function. And Tom would have explained this to you if you watched the videos. If you haven't watched the videos yet, then again, I'll explain it kind of in short form, but you're always expected to know what he talks about in his videos, right? You should always be watching them. What is the inverse of a function? Let me try to make it simple for you. It's like the backwards function or a reverse function or the undo function. It's just, if this was our function f of x, we don't know what it does to numbers. But let's just say we put in the number 5. We put it into our machine, it does something with it, and let's just say it pops out the number 25. So maybe it squares numbers, maybe it doesn't. It doesn't really matter, because the important thing here is, what is the inverse function? Well, what the inverse function does, it will take that number, it'll do the opposite. So whatever this mysterious inverse function is, will reverse what you did. So if it put in you got a 5, put into it, and spits out a 25, the inverse takes the 25 and puts it back to 5. So maybe you squared it, the inverse will be a square root. That's the big idea here. That's what inverses do. In other words, it switches everything about x and y. So what used to be domain is now range. What used to be range is now domain. Okay, so let me try to summarize it here. Two functions, the functions f and g, are called inverse functions only if this is true and this is true. So what this is saying, you will know if two functions are inverses if you put one function into the other, and when you simplify it, it gives the number x. Okay. In other words, let me just write it out here. You know they're inverses if f of g of x is equal to g of f of x, and they're both equal to x. Literally, they just pop out the variable x. So let me show you an example which was done by Tom. You know, this example was already done by Tom, but I want to show you that. Let's see. We need to figure out if they're inverses. We need to show that they are inverse functions. So we take one and put it into the other. We should get x. We do it both times, one for each one. So the first step here, let's find f of g of x. We have to start somewhere. I'm just going to put g in first. That means I put g in. So let's see, I'm going to put 2x plus 1, that's g, and minus 1 over 2. Okay, So that again is putting the g function into the f function. And let's see what happens. Well, on top right away, I can see that the 1's cancel. What does that leave me with? It leaves me with 2x all over 2. And then I can see that there's a 2 on top and bottom, which can also cancel. That leaves me with an x. Now, you know, who cares? It's just an x. It could have been anything. Well, I care, and you should care too, because that's exactly what we're looking for. It's saying that that must be true. If you put one function into the other, it should spit out an x. And it's a good way of knowing if it's an inverse or not. Now, it's only an inverse if it works both ways. Both functions into the other need to give x. So we got to do two things. That's why I put this number 1 here. 2, you know, this is our answer. That's a good thing. I'll put a little check mark on it. That's good. But we're not done. It's only half the story. Let's put the function f of x inside. What does it give me? Well, the function is 2x plus 1. So I'm going to take the 2. I'm going to replace the x with x minus 1 all over 2 plus 1. So you should not have any trouble simplifying this. If you do, you need to pay super close attention and see how I do this. So first of all, I see a 2 on the outside, also known as on the top, and there's a 2 on the bottom. So we can cancel those because it's a 2 on the outside, also called on top. It's 2 on top and a 2 on bottom, they cancel. What this leaves us with, I'm just going to rewrite it. We still have the x minus 1, and then we have the plus 1 left. And of course, they will combine. Negative 1 plus 1 is a 0. They cancel each other. It leaves me x. Okay. So for those of you math geeks out there, and I know some of you are there, like you might not love math, but at least you can appreciate it. Hopefully you can see this is pretty cool. If they're inverses, they'll pop out an x. I'll look at your question in a second, Hamza. So yes, they're inverse functions. They're inverses because f of g of x, I'll only write this out once. F of g of x is equal to g of f of x, and they're both equal to x. So Hamza, you said, will it still be an inverse if there is a number next to an x? No. The only acceptable answer is x. You can't get 2x. You can't get a half x. You can't get an x squared. You can't get an x cubed. You can't get anything but x. So there are certain cases where they're not inverses, of course. I mean, if we look up here, obviously these were not inverse functions of each other because they didn't give out x. They gave a totally crazy function. So just be aware that this is what inverse means. Okay, any other questions? That was a good one. No questions. I'm just that good. Just that good. What can I say? Just explained it well. I'm just knocking it out of the park every time. So I'm going to bring up Desmos. Carry on. The answer must be x, or it can be another answer. Well, Ibrahim, I just answered that actually. The answer must be x. No exceptions. So let me show you what's so important about inverses. I'm going to graph it on Desmos. And again, I'm going to repeat this. You should learn how to do this as well. You should bring up Desmos on your phone and follow along so that you can graph these things. It will help. It will help you understand. Home run every time. Babe Ruth, baby. Okay, let's graph this. I'm going to graph x minus 1 over 2. Sometimes my screen is crazy, so bear with me. X minus 1. Oops. I need a fraction. X minus 1 all over 2. So that looks like this. Big surprise. It's a line. Okay, fine. No problem. The interesting thing, at least it should be interesting, let's graph 2x plus 1. Now, the reason I'm talking about these numbers is I'm graphing this, and I'm going to graph this. So it is 2x plus 1. And look what I get. This is What a graph. Now this might not look like anything special, it's just 2 lines, whatever. But what is interesting is if I compare it to the line x equals 0, or sorry, y equals x. These blue and red lines are perfect opposites of each other. They are perfect inverses of each other. If I look at their table of values, they are perfectly switched. Let me show you. Look at this. Let me try. I'll make it clear. 1 in the original function gave 0. 0 in the inverse function gives 1. Let's see another one. -1 in the original function gives -1. -1 in the inverse function gives back -1. Let me see. There's not a lot of good examples here, so I'll just find my own. Let's just see. In my original function, my red function, that's this guy, the number 5 gives back the number 2. So 5 and 2 is part of the original function. On the inverse function, it should be 2, 5. And look, 2. This is the number, or the point, 2, 5. It is a perfect opposite. It is a perfect inverse. That is what inverse means. And I can do this with a bunch of things. For example, this point here on the original function, 15 and 7. On the other function, I should have a 7 and 15. So 7 is here. So up here, it looks like it's 15. I'll just clear my annotations. I'll go looking for it. Yeah, I have a 7 and 15. I can see it. You know, sorry, the annotations in Zoom are terrible. 7 and 15. Okay, 15, 7. My whole point is that x and y's are switched. That's what inverses do. Okay, so hopefully that's making it a little more clear. I'm trying to give you different tools to figure out how to understand this stuff, and maybe at some point it'll click if it hasn't already. All right. So let's go back to the notes and do a few more examples. So let's try to clarify what I said. First of all, I'm going to put a bunch of stars on this. The range of the original function is always the domain of the inverse. The domain of the original function is always the range of the inverse. Okay? It's switching. I don't know how many times I'm going to say this today, but I'll just keep saying it. I'm going to say the inverse is the change function. And by that, I mean it changes x's to y's, and it changes y's to x's. And that includes domain and range. So the last thing I'll put here, that means that domain and range switch places. X and Y switch. Domain and range switches. Everything gets oppositified. Is that a word? Probably not, but it is now. Oppositified, okay? It's oppositification. So now that I've made you all groan with my terrible jokes, it's not even a joke really, it's just being stupid. Let's try an example. So, given that when we put x into the original function, it gives back a 2. So given that the original function has the point 2, 3, what is the inverse? What is the value of the inverse when it's 3? Well, it's got to spit back a 2. Why is that? It's because the original function, let's just say I had a little table of values here. The original function had the number 2 spit back 3. It's inverse. It's like dark side. It's weird alter ego, like the Clark Kent to its Superman. Switches those numbers. If I put in a 2, I used to get a 3. Now if I put in a 3, I get back a 2. So that's why it gives me this 2 as an answer. So let's see here. What's the answer for B? Let's see who can figure this out. What is the answer for B? For anyone who's sleeping, boo! Are you awake? 3. 100%. Sarah wins the prize. I don't know what the prize is, but she won it. And the way that I'll talk about this, the inverse, 3 on the inverse needs to give back a 2. And so then the function of 2 spits back a 3. Or in other words, if I wanted to write the whole workings for this, I would say it actually spits back a 2. And then f of 2 is, of course, 3. So 2 ways of looking at this. It's kind of like a little game. It's a mental exercise. Ibrahim, inverses don't give back negatives. They just give back the opposite of what you'd expect. So instead of 2 giving a 3, we need to go backwards, and a 3 now gives a 2. It doesn't have to do with negatives. So in this case, f of 2 gives a 3. Then the inverse of that must give back a 2 again, okay? So let me write it clearly. The inside of this must give us a 3, and then the inverse must spit back the 2. So again, this is kind of like a little game. I don't know if I'd say it's the most fun game that I could come up with. You meant to. Yeah, it's not the funnest game, but it's a mental exercise to help you understand what inverses mean. They just take a number, give you the opposite of what you'd expect, or switch them. Okay, so I think I've probably talked about that enough. There's some more practice on this later that we'll cover. So let me get to what I think is a little bit more interesting parts of the inverses. First of all, not all functions have an inverse. It only has a function if it's a one-to-one function. Or in other words, you can determine if a function has an inverse by using the horizontal line test. Well, we just learned the vertical line test. If you slice something down the center and it only touches once, it's a function. If it touches 2 or more times, it's not a function. Well, the inverse, because it has to be this weird function that switches x and y's, instead of the vertical line test, it switches it to the horizontal line test. But it's the same thing. If you cut it through and it touches twice or more, it is not or does not have an inverse. So let's just look at this. Horizontal line test. Horizontal line test tests for inverses. It tells us if inverses of this function exist. So first of all, does this have an inverse or not? Does this pass the horizontal line test or not? It's a simple question. Someone just left. Yeah, it does. Okay, I'm going to do my little test here. First of all, I'm going to take my line, horizontal line test, and check it. No, nope, 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 nope. Touches twice, touches twice, touches twice. So that's a bad thing. It touches twice, which means, of course, it doesn't pass the horizontal line test. So the horizontal line test is not passed. So there's no inverse. No inverse. There is one thing I need to say about this. Something that we do in this section is that we force functions to have an inverse. And the only way we can force them to have an inverse is if we ignore part of the function. So we force it to pass the horizontal line test. What I mean by that is we kind of just ignore, we would say, well, what if this function didn't exist over here? What if we stopped it or started it at x equals 0? So you kind of like delete part of the function, and then we can see it does pass the horizontal line test. I'll say it passes the horizontal line test if we do something called restrict the domain to x greater than or equal to 0. So we say, okay, the function's not so great. It kind of fails the test, but how about you just look at part of it? Maybe is that okay, sir? And I'll say, yes, that's okay. Let's just look at the positive part and just call that our function. And now it'll have an inverse. All right, so that's an important note that's going to come up soon. Hopefully that's clear as mud. Let's try another vertical line test. Very simply, does this pass the vertical line test? Can we answer like that on the test? What, like, well, technically, it doesn't pass the test, but we can just cut it, like just consider half of that. And is that cool, sir? Is that fine? You can answer it whatever way you want. Send me a voice message, I don't care. But as long as you understand what you're talking about. Okay, so my question was, does it pass the horizontal line test? That's a very simple question. It passes, of course it does. There is no point on this function that it touches more than once. So yep. It passes the test. All good, sir. So the horizontal line test is passed. Remember, that means it has an inverse, not a function. It has an inverse. So inverse exists. That we don't know what it is. We don't know what the inverse is. We're about to go solve and figure out how to do that in the next page or so. But we know that it can have an inverse. And that's all I really care about. That's what the horizontal line test does. So let's go ahead and actually find the inverses. So in the notes here, it tells us how to find the inverse. I'm going to follow a set of 4 steps, which is the same as these steps, just written in a slightly different way. Use whichever set of steps make the most sense to you, okay? I just like to, sometimes I like to think about it in a different way because I feel like it helps. So let me just put this here, then we can take a second to think about it. In order to get the inverse, we do 4 things. First thing you do is you need to think about the graph. You can either sketch it or just imagine it and think, would this pass the horizontal line test? If it does, then we can move on to the next step. The second thing we do is make a note of the domain and range. Is there anything wrong with the domain? Do we need to restrict the domain? Is there anything wrong with the range? Is there anything weird about this function we need to be aware of? In C, or the third step, which is the most important step actually, you switch x with y, or switch x with the function, which is the same thing as calling it y, and then solve for the function again. You'll see what I mean in a second. And then in 4, you just need to know that domain and range are now switched. All right, is that fairly clear? Sorry, I have a text from my wife asking me what we're gonna do for supper. It's actually her birthday today. So I'm in the middle of the class and she's just sitting down there like, happy birthday to me. Happy birthday to me. Actually, she's with my son, but he's 2, so it's actually more work than it is fun sometimes. Yeah, I'll tell her, I'll pass on your birthday wishes. Anyway, 4-step process. Let's go through it. Find the inverse for each function. Okay, will do, sir. Find the inverse of this function here. Let me get my colors back in case I need them. Find the inverse of g of x equals 4x. Okay, what does my function look like? Can you sketch it? Well, I certainly hope so, because yesterday we looked at this and we said, okay, what kind of function is this if it just has an x? I hope you know it's a linear. And I hope you know that if this is a 4, positive 4, it means we have a positive a, which means it looks like this. Does that function pass the horizontal line test? Yes, it does. So it must have an inverse. We're not wasting our time trying to find the inverse. Okay, so let me show you what this looks like. The first step, I just did it. Consider the graph and the horizontal line test. Iowa is good. Solved it, it's 1/4x. I agree with you. Let's see. The way that I will do this, I'm going to switch x and y. oh, first of all, my domain and range are all real numbers. So I actually don't need to worry about that. The domain and range aren't special, but I will note them down. That's my domain, and that's my range. Switch x and y. And what I mean by that is replace g of x with x and vice versa. So it looks like this. X equals 4 g inverse of x. I'm going to show you a little easier way to do this in a second, but just bear with me here. So how do I get this? Well, I divided both sides by 4, so x over 4. I'll just put it over here to make sure I have the space. That means my inverse function, inverse g, is 1 over 4x. Okay? That's a different function. It's like the evil twin, or maybe not the evil twin, just the twin of the original function. Okay? Now, the range, the domain and range are still, the domain is still all the x values. The range is still all the y values. But you'll notice, well, we'll notice soon, the domain is the range of the inverse, and the range is the domain of the inverse. I'll get to that more in a second. I'm going to graph this. You're probably sick of me graphing, but you might as well just get used to it, and you might as well try it on your phone, because it's not that hard and it helps you understand. I'm going to graph a new set of functions. Come on, sir. All right, new blank graph. What am I graphing? I'm graphing the original function, and I'm graphing our new function, the inverse. I'm going to check to make sure that this makes sense. So what am I going for? 4x is my original function, 4x. That's what it looks like. I wish the keyboard would stop popping up. And then 1 over 4x, or x over 4. And I'm going to graph the most important part, which is the line x. Now let's look at this. I'm going to make that x line black. Okay, what am I looking at here? I'm looking at the original function in red and its inverse in blue. You'll notice that it kind of like did a reflection about the x-axis. Or in other words, it flipped all the values. Now I already talked about this. Let's just say we have the, here, this is the value 4 and 1, or it certainly looks at it, looks like that. The original function should have the value 1, 4. So 1, and it does. We can check these values and see that they're kind of like perfect mirrors of each other. This value here, look, this value here has a perfect mirror over there. This value here has a perfect mirror over there, same distance. It's kind of like reflected. If you had a mirror on that y equals x, it would like be reflected on either side of it. And the reason I'm spending so much time on this is because it's going to be super important in the next unit to understand this stuff, or even at the end of this unit. So hopefully I'm not losing you. I'm going to bring up the table of values before I stop here. At least, I mean, stop explaining this particular answer. Look at the table of values. We can see that we have some of the same, it's not a very good table of values actually, so I won't talk about that, but they are definitely inverses. I don't want to confuse you by over-explaining that. Okay, let's go back and find some more inverses. B, how did we get 4x? We were given, this is 4x. We started with 4x. So the questions will give us a function to work with, and we need to get the inverse of that. Is that okay? Yes, sir. I'm assuming that's okay. I'm not hearing from you. Going once, going twice, all good, okay. So I would like you to try g of x. Yeah, we're going to do several more examples actually, probably 2 or 3, because this is super important to understand this and it's not easy, okay? In fact, I'm just going to quickly, I'll do B because it's not difficult, and then I'll have you do B, or I'll have you do C. So this question here, this is a linear, and it has a positive A value in front of it. So it should look very similar to the original one. It's just going to be shifted up a little bit. You can check that in Desmos easily. And it passes the horizontal line test, so it does have an inverse. You can also see that because it's linear, there's no restriction on the range or the domain. You can have any X value, you can have any Y value. So let's just ignore domain and range for this question. And I'll show you the shortcut this time too. It's not really a shortcut, but I'll show you. Change X and Y. So X is now on the left. This is now 3 of inverse of G plus 2. And I'm going to solve. I need to solve for this. Right? I'm solving for the inverse function. Bring the 2 over. It becomes X minus 2 equals 3 G inverse of X. Now this is our blue function here. And then divide everything by 3. What that gives us is G inverse is everything on that left side divided by 3. This is our final answer. That should be the inverse. I'm not going to graph that one because I want to save a little bit of time, but hopefully you can see how I did this. And this is the actual answer. You can graph it yourself at this point and convince yourself that this must be true. So I'm just showing a vertical line test here. Okay, so these linear examples are really simple. Can you please try C? Take, just 1 minute, just get the, oh, I forgot to tell you the shortcut. Okay, so before I do anything else, C is X plus a half. X plus 1 over 2. Yeah, all of X plus 1 all over 2, Hamza. So make sure you use brackets if you're going to type it like that. Let me show you the shortcut. So I'll take the same question. I just want to put it over to the side so it's not in the way. G of X equals 3X plus 2. What I'm going to do, and this is what Tom does too, and the reason he does it is because it makes the questions a little easier to solve. I'm going to switch these two values, G of X with X. I'm going to call the function Y. And what I mean by that, look, I've put the X there. 3, I'm going to call that Y plus 2. And the reason we do that is not to add more rules to this. It's because it's way easier to write Y and work with that than it is to write G inverse bracket X close bracket every single time. You'll still get the same answer. So you still go X minus 2 equals 3Y. And you still divide both sides by 3. So we still solve for Y, and it still gives the same answer. The only difference is that at the end, if you're going to solve it with Y, you have to replace it at the end. And the reason for that is no one in the beginning of this question was talking about Y. There was no Y. You made it Y. You chose to use Y. So you need at the end to replace this and put G inverse back in. Okay, that's the exact same answer. Let me just show you the whole thing. That's the exact same answer. You can see this is this. Many, many, many students prefer that other way, which uses Y, because for longer questions, it saves you a lot of work because you don't have to write those brackets out every single time. Okay, so choose whichever way works for you. All good? I'm going to do several more examples after this, but please try C. Okay, just try this question. Just get the inverse. Hamza already did it. Can I get a couple more answers, please? And then we'll move on. Okay, so Kevin, when you put the extra x plus 1, okay. I was wondering what you meant. So I'll do this really quickly so we can move on to slightly harder problems, and then we'll pretty much be done for the day. I'll have to go till 5:20 today. You don't get off easy today. Not like yesterday, but it's not so bad, or at least I hope it's not so bad. So first of all, this is a linear function. Linear functions always pass the vertical line test. So let's just go ahead and do the replacement. X equals 2. I'm going to call it y. I'll replace it at the end. Minus 1. That gives me x plus 1 equals 2y. And then I've got to move it over because there's not enough space for me. If you had a notebook, of course, you can have as much space as you want. Divide everything by 2. That means y equals x plus 1 all over 2. Or you can write 1/2 x plus 1/2. But I'm just going to keep it like this. And of course, I said you need to rewrite the final answer. So if you do not do that, you will lose part marks. It's important that you do. It's just replacing them. And now we're done. That's our final answer, okay? So that is the inverse. Again, I could graph it if I wanted to. It takes very little effort to put it into Desmos and see that they're opposites. But we don't need to, because I know that that's the right answer. Any questions on that before I make it a little trickier? I'll take the silence as a no, as usual. But you know, you can surprise me sometimes. I'm gonna keep holding out hope. I trust that you're all there listening. And you might notice I have a seemingly endless amount of energy. But I can guarantee you that as soon as classes start, I mean, as soon as classes end, I just kind of dissolve into a pile of nothing. So, Kevin, you asked me, do you necessarily have to replace it with y? Well, no, you don't need to use the y. I'm just allowing you to do that as just a tip. If you want to use y, sometimes it's easier. You do absolutely need to switch the functions. So you do need to switch g and x, for example. That you do need. The reason we call it y is because generally we are talking about y equals x. So we just make it simple. Yeah, you just switch places. So you have an x now where you used to have a g, and now you have a g where you used to have an x. Just swap them, okay? That's the big idea. I don't care what you call it as long as at the end you call it g of x, or g prime of x. By the way, have you seen this sign before, this -1? Have you seen that anywhere else before? This isn't, I don't think, the first time you saw this thing. Yeah, it means inverse. And the inverse that we've seen before, and I hope you know this, like sine inverse. Sine of x, of course, we did this on our last assignment, for example. So this would be sine inverse. 1 second. My battery was starting to die. Sine inverse of 45. Okay, so you've seen it before. Of course you've seen it before. And it means the same thing. It's the reverse function. So inverse you've actually done before, just in a different way. Okay, we've got a little bit more to do. This is the first time I'm going to absolutely demand or beg that you watch Tom's video. And the reason for that is because this question 5 was done by Tom in great detail, and it's an extremely important question. The reason it's important is because it originally fails the vertical line test, as you can see, but if we restrict the domain, we can force it to pass the horizontal line test, and then we can find its inverse. I'm not going to do that one here for you, but I will do a similar question, okay? But please go watch Tom's video, even if you only watch the video for that question. Okay, I said it's homework. Some of this will be homework, but not all of it. Let's see here. I want to see I already did one like the first one. I'd like you to try B. And first of all, I'm going to draw the function. I'll give this to you for free. You can graph it on Desmos. It looks like this. That's a bit of a crazy looking function. It's an inverse function. It has this asymptote at 5, but again, that's getting ahead of myself. Basically, all I'm trying to say is that it does pass the horizontal line test. So it does have an inverse. So please solve for the inverse of B. In my other class, not one student got it right, at least not in the beginning. So show me if you can do this. I don't want you to get stuck on it. I want you to try it though. I want you to see if you can get it. It's a little bit of a tricky one. Take, 2 minutes and do this. B. This is what I got. Again, it's very important that you get the algebra skills. So keep working on it. See if you can match my answer or something similar. Okay, so you're saying you got the same answer as me, which is excellent. I'm just going to show you how I would do this, because not every student can solve this so simply. First thing I'm going to do is switch S and Y, I guess. It doesn't matter what the letters are called. So I'll call this S equals 1 over, and I'm going to put a Y there, just to call it something. And there's multiple ways of doing this. The fastest way, 1 over x plus 5. No, not quite, Zara. The fastest way of doing this, and it's kind of a trick, if you have something in this form, where you have something over here, and then something over here. Let's just say we have something over here and something there. You're allowed to switch them, and then it would be in this form. I'm just using shapes because it doesn't matter what they are. You're allowed to switch them like that. And so let me show you what that looks like. You're allowed to switch this with this. There's a good reason for that. It's just that it's a cross multiplication. So let me just show you. Most of you probably know this. If this was over 1, you can multiply these and multiply these. And what that gives us is we can kind of switch the places, okay? But whatever way you want to look at this, let me just say that it's a switch, because most students find that easier to think about. And I'll erase this and put it to the side. Sorry, 1 second. Okay, and when you switch them, what we get is y minus 5 equals 1 over s. And then all I need to do is bring the 5 over. Same idea, okay? Or similar answer to what I had earlier. But of course, we need to change to H inverse. So something like this. That's the same as the answer that I put earlier. This is just another way to do it. as in most cases in math, there's many ways to do the same thing. I'll show you one very quick way I could have done this, because some of you might find that easier. S 1 over y minus 5. Some of you were taught that you should multiply both sides by the denominator. So y minus 5 on this side, y minus 5 on this side. That will cancel that. And what I end up with is this. And then I'll divide by s. And then I'll take the 5 over. Let me see. Actually, I won't divide yet. I'll expand it. Again, there's many ways to do the same thing. This is sy minus 5s equals 1. That means sy equals 1 plus 5s. And then I would divide both sides by s. And that is the same or the equivalent answer, okay? Sorry if I'm driving some of you crazy, you just want to be rid of math for the day, but this stuff is super, super important to be able to rearrange this stuff. And it's important that we cover it, of course. So that's what I'm doing now. Let's see, we have 1 more minute. I'm going to ask you to try, not right now, but at least see if you can do either C or D, okay? I'm gonna assign this one so that we can do it at the beginning of tomorrow's class. I'll start this at the next class, and then we'll move on. We'll do the last sort of, or second last topics in the course. Second last topics in this unit. Okay, so those of you that are listening, I'll stop the recording. Have a great day.